Hello viewers, I am Kausalya. Today we are going to solve problem number 1, part 1 under the category Bode Plot. Problem is sketch the Bode plot for the following transfer function and determine the system gain k for the gain crossover frequency to be 5 radians per second, and this is your given g of s expression. So the first step is we are going to plot the Bode plot. As we all know, Bode plot has two parts. One is magnitude plot and another one is a phase plot. So here in this video, we are going to see how to draw a magnitude plot. Right. So the first step is we have to substitute the value of s as j omega, since this is a frequency response plot. Right. So I am substituting, I am replacing s by j omega. So here you see g of s is rewritten as g of j omega, and here k as such, and this s j omega, so s square j omega whole square, so divided by 1 plus 0.2 in the place of s, write j omega, and here 1 plus 0.02 in the place of s, again write j omega. Right. So the next thing is, since k is a constant, we are assuming by ourselves the value of k as 1, because it will be easy for us to have a magnitude plot. So let k equal to 1. After substituting k equal to 1, just rewrite the expression. Right. The remaining terms will come as such. Then the next important step is we have to find the corner frequencies. Right. So the corner frequencies are nothing but, from the problem you can tell the corner frequency, that is you have to take the reciprocal of the coefficient of s. Okay, whether this terms here in the problem or in denominator, no matter, even we can have this type of terms in the numerator also. Right. So wherever the terms may be, you have to take reciprocal of the coefficient of s. So here the coefficient of s is 0.2. So we have to take the reciprocal. So 1 divided by 0.2. Similarly, here the coefficient of s is 0.02. So you have to take reciprocal. So 1 divided by 0.02. Right. These two values are the gives you the corner frequencies. So here you see we had solved. 1 divided by 0.2 is 5. So the unit is radian per second, and again 1 divided by 0.02 is 50 radian per second. Right. Then you have to name according to the values of the corner frequencies. You see here we are having 5, right? So I am naming it as first corner frequency, that is omega C1. Right. Here next it is 50. So I am naming it as omega C2. Suppose in case if I have corner frequency as 25, then I have to name that one as omega C2 and this 50 as omega C3. That is, the corner frequencies should be named in the ascending order. Right. Since this is the first problem, you just try to learn what I am saying, then you can easily do the remaining things. Right. Hope you people understand how to calculate corner frequencies, right? After finding the corner frequencies, you have to give the name, that is this 1 and 2 in the ascending order. That's it. Right. The next step is forming a table. Right. The table has 4 sectors. You see, the first one is term, second one is corner frequency, unit is radian per second, and the third one is slope, it is decibel per decade. And finally, the fourth one is change in slope, unit is decibel per decade. Right. First, you know the procedure, how to list out the terms here. That is the rule, how to list out the terms. So here the first step is you have to write the individual omega terms. Either they may be in the numerator or they may be in the denominator. Here, when you look at the problem, you see here we are having individual omega terms, right? So in the numerator I am having j omega whole square, right? So the first occupying part of the table is you have to write j omega whole square as a first term, right? That is why we had written j omega square as a first part, right? So to a constant there is no corner frequency. So here no need to write anything. And the next one is slope. So here the rule is a single omega will constitute a slope of 20 decibel per decade. But here you are having omega square, right? So omega into omega. So 20 plus 20 contributes 40 decibel per decade, right? Since this omega is in the numerator part, here we are considering this term as plus, the slope as plus here, right? We are having omega square in the numerator part. So I am writing the first term as this j omega whole square. Since these terms do not have any corner frequencies, the corner frequency is nil here. Since this j omega square occupies the numerator part, here I am including a plus sign, right? So a single omega constitutes a slope of plus 20 decibel. But what about omega square? So omega into omega will contribute 20 plus 20 plus 40 decibel per decade. Right. This is your first step. Then the next thing is we have to list out the terms according to the corner frequencies. You see, the first corner frequency is 5, right? So which term contribute this 5 radians per second? From this term, I had calculated the corner frequency as 5, right? So the next thing is we have to write the respective terms. You have to write the corner frequencies in ascending order and you have to write the respective terms here. Right, this is very, very important. You should not do any mistake over here, right? So omega C1 is given by this 5 and this 5, which term contributes this 5? This term had contributed the corner frequency as 5. So write that term. Similarly, second corner frequency is 50 and write the respective terms which had contributed this 50 radians per second, right? And you see here again we are having an omega, but where is the omega? Omega is in the denominator part. So this denominator term contributes a slope of minus 20, right? Because we are having a single omega here. That too, that omega is in denominator. So I am including minus here. So minus 20. The third one is again I am having an omega, that too in the denominator part. So what is the slope? Again it is minus 20, right? Hope you people understand this one. Then the next thing is change of slope. So how to calculate change of slope? The first step is here we are having plus 40, right? So you just write this plus 40 as such here, right? Then the next thing is we have to move this value to the right hand side. So here I am having minus 20. So I am writing it over here. This plus 40, here plus 40 and this minus 20 is moving to the right hand side. So minus 20. Then 40 minus 20 gives you 20, right? Then the next step is I have to move this answer downwards. So here I am having plus 20. So I am shifting this plus 20 here. And I am again moving this minus 20 to the right hand side. So 20 minus 20 gives you 0. Right? This is how we should form the table. Hope you people understand this one. Right? If you have any doubts, let me know in the comment section. Then the next thing is we have to select two frequencies, right? We have to select a lower frequency and a higher frequency. The lower frequency value should be less than your first corner frequency and higher frequency value should be greater than your second corner frequency, right? Here what are all the frequency values? You see I am having 5 and 50. Right, so I have to select a frequency value which is less than 5 and another frequency value which is greater than 50. Okay, you can select whatever number you want, right? So here, as this is the first sum, I am following the book as such, right? I don't want to deviate. So here I am taking the lower frequency as 0.5 radian per second and higher frequency as 100 radian per second, right? So after selecting these frequencies, the next step is we have to find the magnitude. So the magnitude is generally denoted by this letter A and it is given by, this is the symbol, right, for finding magnitude. So magnitude of, this is our given expression, G of j omega in dB, that is decibel we are going to calculate, right. So the next thing is we have to find the value of A at all these four frequencies. you are having a lower frequency and first corner frequency, second corner frequency and a higher frequency. So we have to find the magnitude at all these 4 frequencies, right? So first step I am considering at omega equal to omega L. Right. The formula to calculate the magnitude is, so we have to consider only the individual omega terms here. So the formula is given by 20 log of, right, magnitude of how many omega we are having individually. We are having j omega whole square. That too, this j omega lies in the numerator. Right. So 20 log j omega square. You see, this is the problem. We have substituted s by j omega and k equal to 1, right? So this is the given expression. So here when you calculate magnitude, you have to calculate whenever you consider lower frequency and first order frequency, you have to consider only individual s terms or individual omega terms. So here I am having this j omega whole square, that too in the numerator part. So we have to substitute. That is the reason why I had written 20 log j omega whole square. So what is the value of omega L? This omega L is taken as 0.5. Since we are considering magnitude, this omega square j omega mod of j omega whole square becomes omega square. So in the place of omega, I am substituting 0.5 whole square. So when you calculate and find the values, you will be getting as minus 12 dB. Right. Then the next thing is we have to move to first corner frequency. Again for first corner frequency also we should use the same procedure. We have to take only individual omega terms. So here again a equal to 20 log of mod of j omega the whole square. So 20 log, this mod becomes, we have to take only the value of omega, right? So here we are taking 20 log omega square. What is the value of your first corner frequency? The value is 5. So I am substituting 5 here. So when you solve this using your calculator, you will be getting the answer as 28 dB, right? Hope you people understand these steps well, right? Then the next step is at omega equal to omega C2, the magnitude is given by the formula change of slope from omega C1 to omega C2 into log of omega C2 by omega C1 plus the magnitude of A when omega equal to omega C1. Right. Since this is the first problem, I am telling you this as a formula. I will explain you later in detail, right? So here change of slope from omega C1 to omega C2. Right, we have to look at our table now. So this is our table, right? So change of slope from omega C1 to omega C2. So from omega C1 to omega C2, what is the value of slope that is changing? Here 20, I am getting this 20 and this 20 is shifted over here. So change of slope from omega C1 to omega C2 is nothing but 20, right? So that is the reason why here I am substituting 20, right, into log of the value of omega C2 is 50 and omega C1 is 5. So just substitute the values here plus, and here the magnitude of A when omega equal to omega C1. You see, what is the value of A when omega equal to omega C1? When omega equal to omega C1, the value of A is 28 dB. We have to substitute this one. So when you substitute the value as 28, here when you solve, you see log of 50 by 5, these two cancel each other and we get 10. So log 10 is nothing but 1. So 20 into 1 plus 28, this gives you 20 plus 28 which is equal to 48 dB, right? Then the next step is at omega equal to omega h. Here again the formula is change of slope from omega C2 to omega h into log of omega h by omega C2 again plus the value of A when omega equal to omega C2. So here the main thing to be noted is whatever thing which we are taking, that at omega equal to omega h we are taking, right? So this omega h should occupy the numerator part and the previous corner frequency should occupy the denominator part, right? So here change of slope from omega C2 to omega H. So here again we have to look at the table. Here what is your omega C2? It is 50. Right. What is the value of your omega H? It is 100. So when you list out in this table, the omega H will occupy the third place, right? Because it is more than 50. So it will occupy this place. Right. So change of slope from omega C2 to omega H. So change of slope from omega C2 is 0. Again, when we have some values over here, this 0 will be shifted over here. Do you people accept? Yes. So the change of slope here is 0 because this 0 will be contributed whenever we have some other terms here. So change of slope from omega C2 to omega H is 0. Right. So here we are substituting the value as 0 into log of your omega H is 100 and omega C2 is 50 plus again the value of A when omega equal to omega C2. What is the value? You see, when omega equal to omega C2, the value is 48 decibel. So we have to substitute this value here. Substitute the value here as 48. Here 0 into anything is 0, right? So 0 plus 48 gives you 48 dB. Right. Finally, we can find out the 4 values of magnitude for the 4 different corner frequencies. Right. So here finally we had formed a table which includes all the 4 corner frequencies with the respective magnitudes. Right. Now we are going to use a semilog sheet and we are going to mark these points. So this is the typical semilog sheet, right? So you have to keep semilog sheet like this. That is, the number should be on your topmost side, right? So here when you look at the bottom side, you see here we have to mark the values of their respective corner frequencies, right? So here in this problem, what are all the values of corner frequencies we are using? We are having 0.55, 50 and 100, right? So here when you look at the topmost side, you see the values ranges from 1 to 1 here. That is, we can say this as, wait, let me zoom and show you. You see, now the figures are clear, right? We are having 1, 2, 3, 4, 5, 6, 7, 8, 9. This means 10, right? So here we are telling this as a decade. So depending upon the frequencies, we have to write the values on the x-axis here. So here I am starting from 0.1. I am taking the first point as 0.1 here. Let it be 0.1. So 0.1, when you multiply this with 10, it becomes 1. So it completes a decade. Okay. So here I am writing 1. So this one when multiplied by 10, 1 into 10 gives you 10. So the next decade I am marking it as 10 here. Right. And this 10 when multiplied by 10, the finally we are having 100. In here we will be having 1000, right? It goes on. Right. But 1000 is not needed here. So I am stopping with 100 here. Hope you people understand, right? How to mark the frequencies on your x-axis, and this x-axis gives you the corner frequencies omega c here. Right. Now we have to mark the respective points. For that, in y-axis we have to mark the magnitude. Right. This y-axis gives you the magnitude part. Here what is the maximum and minimum value of magnitude? Here the minimum is minus 12 and the maximum is 48. Right. So accordingly here I am taking the values here. No restriction that we have to take values only like that. Even you can start from 0, here 50, 100, 150, whatever maybe you can mark. But depending upon the values, here the maximum is 48 and the minimum is minus 12. So I am having the scale like this. So 0, 10, 20, 30, 40 and 50. Right, it is easy, right? The between lines I am marking, right? 10, 20, these are somewhat visible lines. You see, this is brighter line when compared to the rest of the lines here. So 10, 20, 30, 40 and 50, and here again 0, minus 10, minus 20. Right. So what is the value of your first corner frequency? The first corner frequency value is 0.5 and magnitude is minus 12. So here I have to locate where is 0.5 here. So you see, from the top I am having a 5, right? You see, here I am having 5 here, right? So here what is our starting point? My starting point is 0.1. So this is 0.1 and you can have a scale to show. So this is your 5. When you mark down exactly here, there comes a 0.5 here, right? So 0.1 and this is your 0.5. It is easy for us to mark 0.5 rather than counting here and marking. By labeling, by looking at the number 5, you can have a scale over here and you can directly mark 0.5 here. So for 0.5, what is the value of magnitude? It is minus 12, right? So here I am having minus 10 and here I am having minus 20. So in between I am having 5 lines. So this is minus 10 and the next line is minus 12 and next is minus 14, minus 16, minus 18 and finally minus 20. So from 0.5, this is your 0.5. So from this 0.5, what is your magnitude? It is minus 12. So just mark it over here. Right. Then the next step is, for corner frequency 5, the magnitude is 28. Right. So this is your 1 here, but you need 5. So how to take 5? Again, when you look at the top, you see this is your 5. So just keep a scale and you can directly mark the value as, so this is your 5. So here you mark it as 5. At the 0.5, what is your maximum value? It is 28. So here I am having 20, right? Here I am having 20 and here I am having 30. So the 28 lies between 20 and 30. So at 5, here this is your 28 because here 20, right? 22, 24, 26 and 28. So I need 28. So at the corner frequency of 5, I am having 28. So just mark a point over here, right? Then the third one is at the corner frequency of 50, I am having 48. So here you see again, here I am having 10, right? So again from the 10, so this is my point of 10. I need 50, right? So this is 10, 20, 30, 40 and 50. This is my 50 line. You can have a scale and mark down as 50. So at 50, what is the value of corner frequency? It is 48, right? So this is my 50 and the value of this is my 40 and 48 lies between this 40 and 50, right? So here comes my 48. So at 50 and 0.8, I have to mark this point, right? And the next value is 100 and again the magnitude is 48. So 100 we all know. You see, we had initially marked here 100. So from this 100, you just move gradually and the value of this magnitude is 48. So here I have marked those values, right? Somehow I think I had made you a little bit to understand how to mark the points, right? So after marking the points, just take a scale and you have to connect the points. Even you can name the points. Let this be A and let this be B and let this be C and let this be D here, right? You have to mark the points. So first draw a line between A and B. Then connect your B and C. Then finally you have to join your C and D here, right? So this is the magnitude plot for the given problem. After drawing this plot, you have to mark the slopes respectively. So what is the value? The first value of the slope is given as, so from the table, what is your first slope? It is given as plus 40 decibel per decade, right? So here the first line segment A to B has a slope of plus 40 decibel per decade, right? And the next thing is we have to go to the change of slope. So what is the change of slope? The change of slope is 20 decibel per decade. So between B and C, you have to write plus 20 decibel per decade, right? And when you look at the final change of slope, the final change of slope is 0 decibel per decade. So between the point C and D, we have to write 0 decibel per decade, right? So when you look at the graph, it is very clear that you see plus 40 goes like this and plus 20 is bit narrow than your plus 40. You see, when you extend this plus 40 line, it will go like this, right? So when the value decreases, the slope gets narrowed. So this shows plus 20 decibel per decade. And finally, we are having a flat line. What is that indicates? There is no change in the slope. So here we are mentioning it as 0 decibel per decade, right? Hope you people understand the concept well. If you have any doubt, feel free to ask me in the comments. Thank you.